Here we are going to revolve a function over the x-axis. So we're given the function y equals 1/2 x. And we want to revolve that function around the x-axis from x units 0 to when x equals 4, let's say. So if I'm going to graph this function here,
I go x, y-axis here. 1, 2, 3, 4. Alright. And our function
it has points here at 0, 0 at the origin, 2, 1, and 4, 2. So I can connect this, make a line. And so I can revolve that, or our goal is to revolve that about the x-axis. Okay, that would give us a cone. Okay.
that would come down here.
That would look something like this. Okay, so we have now some cone here. That is when revolved around the x-axis would give us, from this original line, would give us that cone. So how can we go about doing this? Well, to revolve around the x-axis, we notice we have a cone here that has many different circles, many different circular areas that are perpendicular to the x-axis, and they get smaller and smaller if we go from right to left, or bigger and bigger from left to right. If we add up all of these areas together, we would get the volume of the cone, and so this is where calculus comes in. Our lower bound, our lower x value is 0, so we want to take the integral from 0 to our upper bound, which is 4. Okay. Now the formula for the area of a circle is pi r squared. So I can put that in here. Area equals pi r squared. All right. And so r is our radius. Okay. But our radius is a changing function. Is 1/2 times x. And we're summing up all these circles. And so we would have to do pi times our radius, which is 1/2 x, squared dx, and this integral would give us the volume of this cone from 0 to 4. Okay, so now it just becomes a simple integration problem. So 0 to 4 of, let's square that, is what, pi over 4 times x squared dx. Let's bring out that pi over 4 here. And we're left with pi over 4 times the integral from 0 to 4 of x squared dx. And now this is a simple integral that we can do. Let's leave that pi over 4 out here. And, integral for x squared is x to the 3rd over 3. And we're doing that from 0 to 4. And that comes out to be below pi over 4 times, 64 thirds, okay, which just simplifies out to be 16 pi over 3, or approximately 16.755 units cubed. And that would be our volume of this cone. If I wanted to quickly check my work just using basic geometry skills of the formula for the volume of a cone, it's just 1/3 pi r squared times your height, and so our volume of that cone would just be, well, 1/3 times pi times our radius being at the base, which is 2 squared, times our height, which is 4, which lo and behold is that 16 pi over 3 units cubed. And so we can see we had the same answer here if we use geometry as if we did it with calculus. Thank you for watching.